Alrighty. Today, saw in an email from somebody, Student Life or something like that. I forget her name. Um, Next week, they're bringing back the cardboard boat races. I don't know if you had a chance to ever see those before. It's hilarious. People build boats out of cardboard and duct tape and have to sail them across or paddle them across the Chancellor's Pond over that way. It's really cool. And then people get wet and it's funny. So that is coming out soon. Cardboard boat race. Let's see. Let's see if I can search. Card. Usually it'll tell like it can figure out. Nope, that's not. Oh, come on. There, this one. That one there. It's part of the homecoming week. Cardboard can't talk. Boat races. So that's not the greatest picture of it here, but one person gets in the boat and has to paddle it across, and it's just hilarious. So there was probably an email sent out to you folks. Amy Finley, does that name ring a bell? I think she's the student something or other life dean, or I forget. But that's always a lot of fun, and I think that's coming up on Monday. So if you wanted to put together a team, you have to register, and they give you the cardboard. I don't think they give you the duct tape though. So like it's people use a lot of duct tape. So I don't know, but that's entertaining. And then for other stuff, then right, we're going to finish up talking about pointers today, and talk about Project Zero. It'll be our first project we're going to be working on using classes, using testing, using exceptions, and using pointers. I'm going to try and put all of it together here, and then we'll just keep on moving through the content as we go. So it'll be due 2 weeks from today. So next Wednesday, not this coming Wednesday, but the Wednesday after, right? 2 more weeks. It'll be due before class starts. And the first thing we'll do in class is I'll go over a solution to it. So generally people have given me positive feedback that seems worthwhile to watch how I might solve the problem. Because like anything, there's 7 different ways you could solve the problem. Right? You don't all have to write the code identically to accomplish the task. So there's different processes people go through and different ways of approaching it, and I'll show you how I might go about solving it. And then we'll talk about project 1 in 2 weeks, and then project 2 in 2 weeks, project 3 in 2 weeks, and then the final group project. And by group, I mean like pairs, maybe a trio. Ideally, it's pairs. So too much and it gets messy. So, but looking at some of these course objectives, these are the important things you should get out no matter who teaches the class here. We're looking at test cases and test plans for unit and integration testing of medium-sized programs. Integration testing is not, I mean, the things we're doing at our scale, sure, our one class will talk to another class. Yeah, we're not really doing anything that large. Well, we'll be honest. So mainly we're going to focus on unit testing here. Right? Does the code we write do what it's supposed to do? Right? And then you could make stub procedures as drivers as needed to do your top-down integration testing here. That's probably how you had gone about it before. You write your main method, you'd write some code to exercise what it's supposed to do. Did it do what it's supposed to do? Right? That's all we had before. Right? I'm a much bigger fan of unit tests and automated testing, and we'll be practicing that in lab today as well. It'll be a lot of fun with Mr. Dia. You said that went pretty well last week, right? Okay, good. I think next week he said he was going to be traveling for some conference, so I think I'll be there. I have to figure it out. We'll see. But it might be me next week, and that'll be a lot of fun. So testing, sure, we could write code in main to do that sort of testing, whether or not we want to do top-down or bottom-up integration testing. Sure, we can go through that, and then practicing some of this data abstraction, data hiding, functions. I didn't get to inheritance yet, we'll get there, and pointers in C++. So trying to knock off some of these objectives here as we go with our practice. Oh, I got to bring chat up on my other screen here. I forgot. Let me do that. Okay, nothing. I didn't miss anything. That's good. All right, I pull up Visual Studio. We can have some fun with pointers. Oh yeah, the pointers project. Awesome. All right, so we did some, hopefully mostly review for pointers. Again, some people said some new stuff. Sorry if it was really boring here. But now we're going to start doing some slightly more interesting stuff with pointers. Okay, so a couple things we want to get into. Make sure I get the right sections here, because learn.zybooks, there we go. Always takes me to the wrong link. So when we look at pointers, the new and delete operators definitely are important. And destructors, is that new? Destructors? Maybe a little new. Okay. All right, that's good. Memory leaks are one of my favorites just because it's entertaining to show you how that works. Copy constructors, copy assignment operators are rule of 3. So that's some-ish new stuff, maybe. Okay. It doesn't always get covered exactly the same, so this is good to know. So let's go write a class here, and we'll practice using some of these things. So I'm going to write a new class here. Let's make this our header file. And what do I want to track in here? Let's have, you can just make it a gradebook. Oh, that's a little too large. So we'll have our class for gradebook. And we'll have our private section, and we'll have our public section. Attributes almost always will be private. And again, there's reasons to make things public, but we're going to follow the good principles and say all of our attributes will be marked as private. If you want access, or if we need to give people access to them, that's really what it comes down to, is what do people need to interact with our class with, right? What are those verbs usually? What are they going to do with our class here? And we'll give them public methods for those sorts of things. So we probably have, let's see, so we need to use our namespace, standard, and we can include string if we want to use some strings. So we can have a string for like class name or something. Right, what class is this gradebook for? Right, we can do that. And then maybe we want to have, what else is going to go in here? Like a list of students, that sort of thing. Okay, well, we can do that. But if we want it to be students, then we should make another class for student. Right, we could just keep like a list and keep a bunch of attributes and have multiple lists. But again, that's not ideal here. Hector, my friend, thank you so much for donating to the Student Scholarship Fund here at the University of Michigan Dearborn College of Engineering and Computer Science. Appreciate having you here. So for our class for student then, right, what do students have? What sort of things do we know about students? A name, an ID number, grade. What do we want to store that? Yeah, we could add a GPA. It might be a little trickier to figure out just if our gradebook is based on a single class to try and say this is an overall GPA. That definitely is an attribute of student for sure, but whether or not we need to use it here might be another thing. So let's grab this one here, our namespace. So we have a string for their name, maybe an int for their ID, and then do you want another integer for your score, like a double for your score? If we're just thinking of like your score for an individual class, maybe we could do that. Sure. So for gradebook then, I've got the class name, then what I probably know how many students are in the class, number of students in the class. I could have something like that. Now, how would I store a bunch of students? Could use a vector, yeah. And vectors are usually pretty handy for that sort of thing, for sure. We can just keep adding here. We're going to do it the slightly harder way because we're going to practice using some pointers.
An array.
An array? Yeah, so if I just said, hey, I want a student array called students. Oh, we got to include student. Now it's unhappy with me. Why is it unhappy?
Because that's Java syntax.
Yeah. Oh my goodness. My syntax is rough. Students over on this side. Okay, can I have an array of student? Sure. Now, how do we do our constructor? So public, our grade book constructor probably needs a string for the class name, probably needs an int for the number of students. What do we do with students here? Right? How would we set this up?
With new.
New, yeah. So we got to use some other syntax, right? I can't just say, hey, it's an array of some given size, right? Because I don't know how many it's going to be, right? So generally with our arrays, and I know that's like the next chapter, things got moved around a little bit here, right? They're typically fixed in size. And with the generic arrays, they're fixed in size at compile time. Do I know what the size of this student array is going to be at compile time? Do I have a constant value at compile time? No, we don't. So we need to be using some dynamic memory. So if we're doing it dynamically, we can use that new keyword, right? And we can get out memory not on our stack. And this is the fun thing. And this is where C++ starts to get kind of fun. So if I'm using my keyword, my new keyword here, it's going to allocate my memory not in the stack, but on the heap, where generally we have a lot more space, which is nice. So we can be a little more flexible, add some more stuff here. So students equals a new that student array of size number of students. Oh my goodness. Students must be a modifiable L value. It is, isn't it? I think. Okay, I'm going to cheat and go look at the iBooks here. That's where it is here. That's my new syntax. Where's my with the pointer? There we go. Students. Come on. Still doesn't like it. Why are you so unhappy with me, friends? Got my syntax. Well, this is not going well.
What if you remove the bracket and students? They just left as blank.
Single pointer. Aha, thank you. This is a little rusty. I apologize. That's right. It's just a pointer, and now it's a pointer to a lot of them, rather than just one of them. In fact, pointers are really obnoxious. But now we have a new array of students here. Awesome. Of a given size. So if I know how many students are in that list, right, we'll go out and ask for a big chunk of memory to hold all these students in my array of dynamic memory. Awesome. So we've got grade books. Right, we got students, and then we should set our other variables, right? Like this class name is the class name, all the boring stuff, and this number of students to the number of students. Okay, so now we can make a grade book. Now we want to like do something with it here. Right, so public ways of interacting with it. String for get class name. These are the boring ones. Get class name. Return this class name. And an int get number of students. Students. Returns this number of students. Now, I probably don't want to give someone direct access to this student array. Maybe we might, but if you give them access to where this array is in memory, they can go and change it, and change all sorts of values. If I just give you one student at a time, we can interact with just a single student. So, might be a little better that way. It kind of depends on how we want to be dealing with our gradebook here. But right now we have a bunch of empty student spots here. So I need a way to put a student into that location any way to get a student out of that given location. And it's all going to be index based, right? So I'm going to have so many indexes, 0 up to but not including this number, and I can add students or take them out or get their values out from here. So maybe just a void for add student. So if you give me a student, I can go put them in that array. It will take our this students. We also need the index number, that's right. And in the index of the index, and we can assign it the student. Right? You tell me what student to put in there. You tell me where it goes in my list. I'll go add it. And then a type of student or get student, given an int for the index, and we'll return the student. Okay, so my class gradebook has a bunch of these other ones. Right? It's like just a collection of these others over here. So we can kind of interact with it. We can get them out. We can add them here, and then whatever the student class lets us do, we can go and interact with the students we get in and out of here. Right? Okay. So in student, then what else do we want to be able to do with students? Sets and gets are boring. We can add a couple here. So how about a constructor student that takes a string for name and an int for the ID. Now your score, when we make a brand new student, we could just default it maybe. Score, maybe default to 0 until we know otherwise, or do you want it to default to 100? You guys want to default to 100, right? It's probably a better default for you. Yeah, so we'll assume you have an A until we find out otherwise. But it's a good assumption. I like that. So we'll say this name equals the name, this ID is the ID, and this score is the score. Right, and then some gets, string for get name, returns this name, and then for get ID, returns this ID, and an int for get, oh, this was a double, right? Yeah, this should be a double. There we go. Make sure I match my types here. A double for get score, because you want those extra partial points in case we round, right? We don't want it to truncate any decimal remainder. Like there's 93.9, you really want to be an A. You don't want that rounded down. It's no fun. Turn this score. Okay, and then we need a way to set the score. So we'll just take, hey, here's your new score here. So avoid method for set score, given a double for score, and my this score can equal the score. And we could do some sort of validation here if we wanted, like, hey, is the score between 0 and 100? You're pretty sure you can't get a negative score, right? And this is our class. We can define any of those sorts of rules as we want here, right? And if we wanted to raise some exceptions, we could do that sort of thing. There's no extra credit. I don't really understand why some people give extra credit in college classes. I feel like that's a primary school sort of thing. Like you know what the work is, you can do the work. But maybe people think I'm a jerk because I don't give extra credit, but that's just me. So we can do some validation, right? We can check, hey, if the score is less than 0 or my score is greater than 100. If it is, we should throw I like these logic errors here. A new logic error. I have it here. I had to include error. That's what it was, right? Yeah, the include standard exception. There we go. I like when it does the typing for me. That's awesome. So invalid score. If we wanted to be more specific, we could do like a too high or a too low, or that's okay. I don't care to be all that specific. We'll just tell them it's invalid. So when you try and set it here, it will just crash unless you catch that exception. Right? So whoever's using my student class has to deal with it. We're saying student can't be put in this bad state. Right? We're protecting the integrity of this class. It's one of those design ideas here that if this is truly an invalid range, don't take it. Right? Weird things will happen if you let your classes get into invalid states, and then other functionality depends on those. Now, for our student here, probably doesn't really matter much at all. But if you're doing something more interesting and you use some of these values for calculations and you get negative values and all sorts of funky things here, bad stuff happens. I always like to give the healthcare example. I've got this little thing in my pocket. This is my insulin pump. If bad stuff happens on my insulin pump, it will literally kill me. Like, so I appreciate all the validation and work that goes into this FDA certified device here because it helps keep me alive. There was the big, probably years ago now, where people are like, oh, you can connect over Bluetooth to it and someone's going to do bad stuff. Well, no, you can't. But now they're opening that back up with their new release here, so you can control it from my phone, and then there's this whole process of syncing it and making sure it's only my phone that can connect to it. And turns out it only works on the flagship line phones. So the cheap phone I got because my son has broken this 3 times, and I'm not getting one of the fancy phones, won't even run it here. So I can't control it from this phone anyway, which that's okay. To get your FDA certification with mobile devices, you have to like test on each individual device itself. So they're not going to go through that work and submit all the paperwork for every single Samsung device that comes out. They're going to take their top line ones. So anyway, validation is important, right? Depending on what we're doing. All right, so we got our logic error if that was bad. Now we're taking a score up here and we're setting it. So that's probably not what we want to do either, right? So let's not do that. Let's just call our set score method here, given the score, where we're already validating. I don't want to have to do that same code twice, right? Let's just use our function. We already wrote the method. We'll do it here. All right, so back to gradebook. Now it's saying, uh-oh, there's no default constructor for student. We wrote a constructor for student that needs a name, an ID, and a double for score. Now I can't just make 30, 45, whatever empty students because there is no empty constructor. We'd have to go and set those values. Okay, well that's kind of a bummer. So we can do one of two things. One, we could have them pass in all of it and just take the list or an array. Or that feels ugly, not super great here. Or we can go and add a default constructor back. But if we have a default constructor, we need a way to set the name and ID. Right? The only set we had was score. So okay, we can go add those. Let's go add that default constructor. Right? Or can we just make all these optional? That might be even easier then, right? We just say, hey, it's an empty thing or 0. I like the optional. Now this is no longer a problem because if they're all optional here, then I can use a default constructor with no arguments. Right? Save this little typing. If you want to make your own, go for it. Right? You could just make your own default constructor. Is that one's okay? Why? Okay, cool. Now, but we still need those set methods, right? So void for set name, given a string for name. Oh my goodness, that's the wrong arrow. It's name, it's the name. Need a little more coffee. Set ID, int ID, ID is the ID. Okay. Now we can go and set them. Yeah.
What would be more efficient when you're creating a default constructor to make options, when the argument's optional, or to make a actual default constructor?
So this syntax here is actually just a shortcut to writing out a second constructor. So behind the scenes, it essentially has now 4 different constructors that you can call. So you can call it with no arguments, you can call it with just the name, call it with just the ID, call it with just the score, or like those combinations of. So efficient-wise, it's just how much typing you want to do. Like performance-wise, it actually has those behind the scenes. It's just this is shortcut syntax for us. And when we go compile it, it will make all of the other constructors for us. Does that answer your question?
Yeah.
Okay. All right, so now we can make our list of students, we can set students, we can get students, and we can start interacting with them here. All right, awesome. Now, back to our main here. Let's see, maybe we'll just throw this at the top here. So if I want to make a gradebook, how about this is CIS 200 gradebook. Yeah, we should probably include that, right? Include gradebook. Now there's no default constructor. Okay, right, what do we need to give gradebook? We need class name and number of students. Sure, class name CIS 200, number of students, I think we're at like 35 or something. I forget, it was more than I thought when I looked. because apparently you can still add the class the second week, which is sure. Have you ever done that? Like get in a class the second week and have missed the whole first week? Oh, okay. I never knew that was a thing. Once. All right, so we got our grade book, right? And then if we could go through, and now for 35 students, we can go and get some names, get some values, whatever we wanted to do here. We can go and interact with it, and maybe now we can go ask them, hey, what it is, or might just be easier for us to just pretend, not do all that user input. But if we want to do some testing of it, right, and try it out and see how it works here, right? We take our 200 gradebook, want to call get student of, I don't know, index 0, right? Why not get that first student here? That will give me a student. Then I can dot and I get all their methods. Right? We're just chaining these things together here. So gets a student out of that student object that I have. Now I can go and set some of these things here. So we'll add Bob. And our 200 gradebook, get student. Now this is a little bit annoying to have to write all of those. So I could just say, hey, I want a student. Here's Bob. Right? It's going to be this one. And then I can say Bob dot. Right? Just different ways of going about it. This way I don't have to type this more than once. It'll do the same thing for me. Set ID, Bob's ID is probably 123, and we can leave Bob's score at 100. We'll say he's got a pretty good score here, right? And we can go through and we can make our grade book. Okay. So if we, let's see, this one's 35 students, not going to be a whole lot here. Let's try a silly thing here just for fun, and let's see what happens. So we'll say for int classes, class index, sure, 0. Class index is less than, let's try like 1,000 of these suckers and see how far we get. Class index plus plus. We'll take our gradebook, gradebook equals a new gradebook, some class, and we'll just say like 50 students each. Oops, gradebook. We're not even using the pointer yet. We'll see if it can't load like 1,000 of these gradebooks all here in memory. And we're just pasting them back on top of each other, one after another, one after another, one after another, right? We're not doing anything with them. We could, but maybe we wanted to make a list of gradebooks. I don't have 1,000 classes. But if we were like, hey, let's load all the gradebooks for the school, we probably have more than 1,000 classes or sections, right? Each individual one. We could do something like that. So I'm going to put a breakpoint in here and see if we can't run a couple of these. So with the debugger, it shows you a couple of cool things over here with this diagnostic tool section. I don't know if you've ever paid attention over here, but it shows you this one's CPU, that's session. So I go over to memory usage. Here it is. So okay, it was still in the summary. I just had to make that bigger. You can see it's not using a whole lot of memory right now, and that's okay. So we'll just step over and try and do a bunch of these. See how far we get. What's our index? Class index is 11. All right, yeah, still not even registering on here as we're loading these items into memory. Let's go. So start task manager here, so we can find it. Studio, our process. Let's see. Is that gonna put a breakpoint down here? See if we can't load all these up here. There it goes. Now we're using a lot of memory all of a sudden. That was fun. Is it doing it for us? Continue. Take our breakpoint out. Continue. All right, we loaded all 1,000 of them. Did we get this to spike? And get it to spike. Yeah, so this is not, it loaded them too fast here. Let's try using a pointer. We'll say gradebook equals a new gradebook. So if we load it in heap memory here with our pointer notation and use our new syntax, Try putting a breakpoint back here. And we'll load a couple of these. So we'll just step. How many do we get? Come on. Still not showing me? Continue. All right, so using some, it's not graphing it very well for me. I want it to show the memory usage. Take our snapshot. So we've got some space here, not a lot here, but in our heap, some amount of kilobytes. We've got our student array, size in memory. Not a ton of space here. Like if we think of these as bytes, right? This is only kilobytes here. Not too big of a deal. Let's run a couple more. Gonna get like 1,000 clicks here, right? This is good practice for playing first-person shooters. And I take a snapshot again, and it's gone up. I can take a look at this snapshot. Right? We've got a little more. 78. What was from 16,000. We're using more memory here, but I'm not keeping these around at all. I'm just saying, hey, make a new one, and then it should go away, right? But when we allocate memory, this was the whole point of the exercise here, looking at this memory usage here and making our own memory leak here. When Gradebook uses this new notation and allocates a dynamic array for students, it goes out and says, hey, operating system, I need a place to store, some number of students here in memory. And your operating system says, oh, sure, here you go. Here's a chunk of memory. If we don't ever tell the operating system we're done with it, it doesn't know we're done with it. So the more of these things we load and create and allocate, the more memory it's just going to eat and eat and eat and eat and eat and eat. So eventually, see if I can take that breakpoint off, see how far we got here. Let me do one more snap. There it goes. Now it's looking pretty. Look at this. Now it's cooperating here. You can see it's going up and up and up. And again, we're not like using tons of memory here. Take one more snapshot. Now we're at like 7 megabytes worth of memory. Yeah.
Instead of clicking one, why don't you just change it to over 1,000?
Change. Oh, to allocate more of them? I wanted to show like, hey, once I have 10 of them, and once I have 20 of them, once I have like 30 of them, I kind of watch it escalate. If we just allocate all 1,000, it goes from 0 to like that super fast. Like this way, we kind of see it trending up was sort of that goal here. And now we can take a look at our heap. So decent number here in our student array. Right? The student array, we should only have one of them, right? But we never gave it back to the operating system. We never deallocated that memory. We used our new keyword to get that memory from the operating system. We never said we're done with it. Okay. It's a whole long story to get into. This is what destructors are for. Does those ring any bells? Are we finally getting to something new? Or wait, or is that you've already talked about it? I was excited for a minute. Is it new? Yeah? Okay, one person said it's new. That's exciting. New stuff is fun. I like new stuff. Much better than review stuff. All right, so we'll stop debugging here. So to make sure we are unallocating or freeing up the memory, we need to write a special method or function called the destructor. Yeah?
I was told, I took C++ before, and the professor there told me that memory
that would, so restarting your computer would definitely free up all your memory. Yeah. Yes. But we can make C++ give it up. It just, you have to do it. So it's another step. Yeah. So what our technical term for this is a memory leak. Leak's kind of a funny word there because like it's not going out anywhere, but we're just using more and more and more of it. I don't know. I feel like that's the opposite of leak, where like you're not losing it, you're just keeping it. But that's okay. Everyone calls it a memory leak. That's what it is, and I'm just confused by the term, but that's okay. So the longer your program runs, the more memory it uses. is sort of that idea here. So if we were to keep this gradebook up and running and have everyone enter classes and enter their classes and enter their classes, and thankfully we have a website for it, but if this was our tool for managing grades, right, by the time the 10th person had entered their gradebooks and then the 100th person entered their gradebooks, right, we'd be using more and more and more memory because we never gave it up. Your question?
I think it's called that because the longer you're using it, the more memory leaking out. And
So the memory itself is leaking.
I mean, it's being used. It's not
Yeah.
like physical, but yeah.
So you've used more. Okay, so like if I look at my water bill, if I have a leak in my faucet, I'm going to use more water over time. Okay, I like that. That's fun. All right, so to write a destructor here then, let's go back. And the destructor is a special class function that destroys the memory. And to write a destructor, it has some fun syntax where you use a tilde sign here. So it's the opposite of a constructor. The tilde sign is the shift accent character above the tab key. It's a fun little character here. So we say tilde gradebook is our destructor. And what happens is when our object is removed or gets garbage collected, it goes out of scope. Right? That idea that we have this scope, if it's inside that set of curly braces, it's in scope. Once we're gone, we no longer have a variable that references it. It can get cleaned up. This is our destructor. So to do that, we need to delete our student's pointer. Del? Oh my goodness. Del. Delete. Just delete. 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 Way too many syntaxes here between all the different languages. Drives me crazy. So deleting students here will delete the pointer. Free up the space. Right? Should we try it? See if that clears it up for us? We'll run our program. See how we did. Right? So we'll nope, we have still using 8 megabytes of memory. I don't think that worked here. So the problem with this delete syntax, and again, I just find it really obnoxious here. If you are deleting an array, you have to tell it you're deleting an array of pointers, essentially, rather than just the very first one here. So when you say, hey, I want an array of dynamic memory here, you actually get like that many pointers reserved in memory. When you call delete, it only deletes the first one. So if we're making 50 each time, we've deleted 1 out of 50. So it's not super ideal here. So delete array braces here will delete the entire array worth of pointers and free up that memory and tell the operating system, hey, I'm done with that space. I don't need it anymore. Now when we run it in debug mode, let's check out our memory usage. It's not even showing on the scale, right? Now it's all cleared up here. If I take my snapshot, we're back to like 6K, right? No, is that not 6K? Hang on. Is that the same one? No, we're still using it. Still using it. So we haven't called, looks like we haven't called our delete method. So let's go and delete our gradebooks when we're done with them. Because we have a pointer here and we never freed up this pointer. Right? The gradebook was going to free up the student pointers. We never freed up the gradebook pointer. So now we'll go add that delete notation here. So then we can delete gradebook. Now when we try it, now it should free up the memory. This is why pointers are obnoxious. Now we're back. Okay, 57K. Hooray! So if you tell C++ you're done with the memory and it's free to delete, it'll delete it. When deleting, we'll call that destructor and add that back. Yeah.
So, okay, now think about it. I'm gonna answer my question because I was gonna ask, like, if you wanted to delete instead of array, like a really complicated class or data structure. I mean, I would assume you wouldn't need any basic syntax, right? You say delete and then gradebook, right? Gradebook, for example, whatever, right? And then it would just delete it.
It would delete the pointer and call this destructor. So if we put it in debug mode, we can watch it call. Let's rerun it here. We'll watch it call the destructor. If you step into your code, we'll say, oh, hey, you went to the destructor here. No.
So that syntax is specifically for primitive arrays.
For pointers.
Oh, for pointers. Okay.
Yeah, so any pointer you use, you can delete the pointer to free up the space.
Okay. The
So-
delete brackets, that's for the array of pointers?
Yep.
Too?
Yeah, the dynamic arrays. Yep. Now, the fun thing is, if student also uses dynamic memory, we can't just delete our array of students. We have to delete each student to make each student give up its dynamic memory, its pointer memory. Then we can delete our array of them. So it gets really tedious here as you start having objects that have their own pointers and trying to clear these things up. So dealing with pointers is just obnoxious. But that's okay. They're powerful. You can do some cool things with them. And if you can pass around a pointer to something, it's much faster to pass the pointer to an object than it is to pass all of its attributes. I'm trying to make a copy of it here. Yeah.
So, actually, no, I feel like you just answered my question. I was going to ask about your deleting gradebook, how that affects the student pointers.
So it deletes our array of pointers of students. Yep. But like say, if a student then had something here, we wanted, I don't know, int for scores, array equals a new so int pointer. This syntax drives me nuts. New int array 50. Right, so if student is allocating dynamic memory here, and it's not freeing it up, we're going to run into trouble. Let's just continue here. You'll see, oh, hey, look, we're using a bunch of memory. We have these int arrays that never got cleaned up here. And we're using 10 meg or so worth of memory here. So it's this sort of cascading process. So you need to know what that class is doing, or just always call delete on it. And that's our other option. So if we don't know what that class that we're making an array of does, or we're making a pointer out of does, we got to delete it. So we happen to know what our code is, and we can go make our own student destructor. Now, okay, this was no good here because I can't actually delete scores. It only exists in the constructor. And I've got no way of getting at it again here. So we need that to be an int pointer scores here, there. And then I can delete scores from here. Right? I can add my destructor. We'll run it. And snapshot. Still have some, right? We didn't go and delete. This is not as much though, right? It's only 7,000 bytes. Do we have one more? I think we made one more, right? Where did our code go? Yeah, from our CIS 200 gradebook. So we deleted, the rest of them got deleted up, which is nice. Yeah.
In the situation where it is only, like, for example, you have something that only exists in a method, right? And you want to get to it, and it's not a variable of a class, how would you delete it? How would you construct it?
You can't. So you've done a bad thing. If you're allocating memory in a side of a local function, you're screwed. So you are just leaking memory everywhere. So it's real bad to allocate dynamic memory and not clean up after yourself. And if you allocate it and don't have a class level reference, you can't destruct it. So it looks like we got lucky. Our destructor is taking care of that as we destruct students here. So let's go back one more time, watch the delete happen, look at all the code. You spent a lot of time using the debugger in the last class, right? Or is this all new stuff with the debugger? I feel like that coverage varies sometimes. The debugger is your best friend when coding. This is how we see what happens and what the values of things are. I'm going to step into delete gradebook. We're about to delete students. I'm going to step in here. Now we get the student itself is being destructed automatically, which is nice. So if there's the destructor, it'll run. And then we can go and we can free up that memory for that student. For all the students, right? That's happening. So as it's deleting the array of students, it's deleting all, I don't know, what do we say, 50 of them here. So it'd be a lot to step through. Oh, We can step back out. We finish this one, step back out, and we finished our delete for the gradebook. So the destructor. So we need destructors if we're working with dynamic memory and pointers to make sure we're freeing up that space. Now, if you only have like a single pointer, you're probably not going to notice there's a memory leak, but you've still done a bad thing. We should feel bad about it. So if we're using our pointers, we need the destructor, right? So like if we're taking advantage of this new keyword and using pointers, we need to destruct to make sure it gets cleaned up when we're done here. And that's sort of what this is all looking at. How do we clean up after ourselves? Then the next fun thing we can do with classes. How are we doing on time? Ooh, that's not great. 2 additional constructors here, copy constructors and copy assignment operators. Not exactly a constructor, but similar here. The idea that if I want to make a copy of student, here, we'll work with student here. If I wanted to make another instance of student using one student, maybe we'll do a gradebook. That might be easier. So if I wanted to say, hey, this gradebook here, gradebook CIS 200B or something, gradebook equals my CIS 200 gradebook. No, CIS 200 gradebook. What happens here? Do I have a copy? No, there's no copy. We now have 2 references to the same object in memory. Right? You modify one, they're both essentially modified because there's only one of them in memory. So this is not ideal. So this is trying to assign something here. So we're assigning a value. If I wanted to make a copy, we can add the copy assignment operator. You get some more fun syntax here. So to make a copy assignment operator, operator equals constant reference to something else. This is real crazy looking here, but we'll get there. So in gradebook, and this is if we want people to be able to do this. Right, so we say this is a gradebook reference is the type being returned here, and then it is the operator equals. So the operator equal sign will say if I use the assignment operator, this is the code I can write. That should happen here. And then given, and then we say a constant reference. So constant, and this is our gradebook reference. Gradebook, sure. They like this object to copy. I think that's fine. Just, I don't know, not a big fan of that term. So if you're going to copy it, we want to go copy it. To do that, then, with the constant reference, we are guaranteeing that we're not going to change this gradebook. That's why we have the constant flag here. We're saying, hey, I'm not going to change this one here. So we need to make another whatever we're copying here and assign it to our pointer. Now this one is not a very interesting class. It just has, what does it even have in its constructor? Just some data object. So whatever its attributes are, we need to go and start assigning those attributes. Using a dynamic list of students is a little messy here. Right? So I can't just say, hey, my, first check if this does not equal the gradebook. The reference to the gradebook. So if we are not itself, we want to do some work here. Right? This is the current instance being worked on, and then the gradebook reference is what's being passed. So if in my code here, that was my first typo, CIS 200B equals gradebook. This is the this here, right? And this is the gradebook to copy. It's what's being given to the assignment operator. Got to read these kind of funny. So these would be the same thing. I'm trying to assign something to itself. There's no work that has to happen. right? We just skip. It's a no operation. But if I give it a different object in memory, then we need to go copy, right? So then my this class name equals the gradebook.class name. Sure. My this number of students equals the gradebook number of students. Now this list of students here, I don't want to just say, hey, it equals, right? Because then I'll still have two objects pointed to the same location in memory. It's not a real copy at that point, right? If I say this array equals that array, right? Still pointed at one. So I need to go and make new memory here. So my this students equal the new student array size of number of students. Then I need to go loop through and copy all of them over. So for index is 0, index is less than number of students, index plus plus. Now I can go copy them. The problem with copying student, though, is I'm still going to have two objects, two variables pointed to the same location in memory. Right? I can't say student equals the student of index. We have to go and copy that one too, which is really obnoxious. But we can. So we can say my this students at index is equal to my gradebook dot students at index. If the student class has the assignment operator, copy assignment operator, we could do that, right? So right now isn't and the term here is a deep copy. So there's deep copies and there's shallow copies. The shallow copy is when you just have two things pointed at the same location in memory. It's not really a copy. A deep copy actually goes and makes a copy so you have new objects in memory here. So we'll fix this in a minute. We'll come back and write our copy assignment operator for students, and then it will work. So we need to go through, make that array, make our copies. Yeah?
So data types like integer and double, they have deep copies like built into their class.
The primitive types,
Yeah.
we would use the values, right? If we just use the variable name, it's the value, it's not a pointer to it, right? But I have this array of students here.
What about the string?
String is a type. It's a class. It's not a primitive type.
Yeah.
But there, you can change it, can't you? I think you'd have to go through the copy process. It might have a copy assignment operator. I would just have to Google it. I think it probably does. I'm trying to remember now if we assign two strings to a variable and change one. We could try that later and see. But now I've mostly made the copy here, right? And then when we're done, we're going to return. So we said we were going to return a reference to a gradebook here, so that when I say, hey, this gradebook should equal something, it will equal a reference in memory, right? Because this is really a reference. Right, when I have a variable here. So then we can say, okay, we're going to return dereferenced this, because this is a pointer to the current instance. So dereferenced this is your memory address, your actual reference to where this thing is in memory. It's real ugly real fast. I'm sorry. Okay, but now I can make two different gradebooks in memory. If we run this one in debug, and we step in. Oh, it didn't even step into the code. Why didn't it step into our code? That's unfortunate. Let's see if we can't find our gradebooks here. So we have the CIS 200 gradebook and the CIS 200B gradebook. Is this the same address? 5D. It is. It didn't do it. It didn't run our code. Gradebook. Why didn't it run our code? Typoed something. Not doing it. So we don't have the actual deep copy. Why is it not running? Operator. Constant object. Come on, gradebook. It's 200. B. Should have just done it. Okay, so let me try one more line here. Is that what it is? CIS 200B and 50. There we go. That's just probably it. I'll try it this way. Okay, now if I step into, there we go. So my apologies. This syntax here, where I tried to copy it the first time, was wrong here. We need to have the object first be created. Then this is saying, here's a reference being assigned another reference. Now it's actually matching. Sorry about that. So now we're getting this copy assignment operator that's running here. And we can step and step and step. They're not the same gradebook. Go through and copy all of our students, on and on and on, and continue. So now if we look at the 200 and 200B in the debugger, the 200B is at this, 9B8, and the 200 gradebook is at 9F8. So they're different locations in memory for these dynamic arrays of students. Finally got some new memory here. Now, what's annoying with debugging dynamic arrays, notice I opened up students here. It only shows me the first one. It doesn't look like an array where I can open up and see all of my different indexes. And I hate that. But it's what we get in the debugger. Again, why vectors are great. Vectors are fantastic. All this work to avoid the vectors. All right, so now we are assigning students then. So we're assigning with the assignment operator so I can make a copy. And why this is good is if I had done the shallow copy and then deleted one, right, it'd get removed and I wouldn't actually have that copy existing anywhere. So if I were to go and make a copy of the gradebook, like, keep one of these around and assign it this gradebook that just got created in memory, once I go delete it here, it's gone. I don't actually have that copy because it was shallow. What was there got erased in memory, essentially. And that's not good, right? So if you want to be able to keep an actual copy around, we'll write that. All right, the next piece that we do is we use the copy constructor. The copy constructor says, hey, make a copy of that object for me. And the syntax is a little funny here. So you'll notice when we looked at like making a gradebook, another gradebook. I don't know if you noticed with IntelliSense, it said, hey, there's two constructors. And that's kind of confusing because you only wrote one of them. So the one we wrote is this one. You give it the class name and the number of students. The other one that exists is a copy constructor. The idea with the copy constructor is you give it another object of the same type to copy. Okay, so if I give it another gradebook and say, hey, let's give it the 200 gradebook, let's see what we get. So we just, I don't want that one here. Let's continue. There we go. So we're about to run the copy constructor. No code to step in. If we look at another gradebook and the CIS 200B gradebook, this 9B8 memory for my student array is the same as the 9B8 memory for this student array. We have a shallow copy. So the default copy constructor is a shallow copy, which is probably not what we want. If this student array gets mucked with, now my student array and the other object is using that same location in memory. Bad stuff happens. So if we want to be able to do this and have a nice, proper deep copy, we can write our own copy constructor. So that's a gradebook constructor given a constant gradebook reference here. Basically the same thing, right? We want to go through, copy them all out. As long as they don't match. And again, they probably shouldn't match at all. Not going to, I don't think we ever bother with that one, right? Yeah. don't even need to bother checking. Because this is the constructor, it won't exist beforehand anyway. What was it telling me? Gradebook, number of students is uninitialized. Always initialize member type. Students is uninitialized. Oh, okay, it went away. Sorry. It was inside that if block, so I was worried that it might not happen. So this is our copy constructor. This was our copy assignment operator. Is that useful to have those notes? Maybe? Okay, sure. So now when we run that copy constructor and we step in, we get to our copy constructor code that we wrote. Good, life is good. This is why we try these things, right? Make sure we go and copy, continue on. And now we'll see another gradebook. Its memory address for students is 5F8, and we copied CIS B is not that address. So we haven't, sorry, that's real small on the screen. But now we have made sure we successfully have a copy. That's a lot of work to deal with making sure we have proper copies. But if you don't want shallow copies, because bad stuff will happen if we have shallow copies, like you probably don't want to replace the wrong student, right, or update the wrong student and have it update in someone else's gradebook. Right? This is the right thing to do if we're working on it this way. Yeah.
So for the majority of the classes in the standard namespace, will they already have the copy constructor like this implemented? If I were to take out like on a map, copy a map, would it just do a shallow copy then, or do we have to also make a deep copy constructor?
I'm not sure. It's C++ standard lib deep copy. Let's see what Stack Overflow says. Clone function, copy constructed. Oh my goodness, that's ugly. I'm thinking yes, but that's would probably need a little more Googling. Yeah, that's the fun thing is whether or not they're implemented. You can't tell just by, hey, can I assign one to the other? Go here, right? Because you couldn't tell which one it did. We had no idea. So putting those all together here then is this idea of the rule of three, right? If you're going to have a destructor, you should probably also have a copy constructor and a copy assignment operator. If you need the copy assignment operator, you should probably have the other ones, right? Like these three come hand in hand almost all the time is the idea, because it means we're dealing with dynamic memory. And if we're dealing with dynamic memory, we need to make sure we're properly copying and allocating new dynamic memory, properly assigning and allocating new dynamic memory. So if any one of them does it, we need to be doing all three, essentially. All right, new arrows, deletes, cool. Memory regions, awesome. The first linked list is fun here. This, we'll get more into this later here, but you can read through and see where you keep lots of pointers around. So we should talk about the project here. So let's go and look at project 0. So due in 2 weeks is going to put us at the 28th at 11 a.m. Right? Oh, 0, 0. There we go. Probably about 10 points. We'll get into the specifics here in a little bit. So for project 0, excuse me. Do any of you play Pokemon Go?
When it was big in 2016.
You don't anymore? You got to catch them all.
3 days.
For 3 days, yeah. Okay, while it was big, that's fine. The game club here on campus, you can find through Victor's link, has a group for Pokemon Go through them. So if that's your thing, check them out. They do all sorts of other games too. And they would love new members, I'm sure. Victor's link has all sorts of cool stuff, I found out. But check them out. But we are going to do our own little Pokemon catching activity here because we can. It'll be fun. So we're going to write a class for trainer here. The idea with the Pokemon trainer is you go around and you catch Pokemon and you train them, and then you make them fight. because that's not weird at all. Make our little pets fight each other. I didn't make the show. Okay, so trainer will have attributes for name, level, and experience points, and a list of Pokemon, or an array, a dynamic array of Pokemon that you have. A dynamic array of type Pokemon. But you know, that's a trademarked word. Maybe we want Pocket Monster. That Pokemon Pocket Monster, right? That's where it came from. Right? Is it really? Oh, wait, did they trademark the full name? Fighting Pet. Or Fighting Pet. Okay, totally unrelated to this copyright material here. Sure. All right. So we'll have all this for the trainer class. Okay. We will include our destructor, copy constructor, and copy assignment operator for trainer. Here. Probably also need the number of Pokemon that we have, right? Or max number of fighting pets. Apparently you can only carry so many at a time, but if you pay money, the game will let you have more. Who knew they would want to take your money? There's ways you can do it for free, of course. But if you want to get ahead faster, you can just pay money, pay to win. That's the good style here, right? You give it away for free and let people pay to win. Is that how games work nowadays? Some of them, at least. I am fond of the games where you pay for like style things, so you can still play for free. But we're going to have ways of interacting with trainer. So trainer needs public methods for set and get the attributes. Right? You should be able to change your name if you want. Probably don't set your level, but that's okay. We don't need to get too complex here. Ways of having experience points. Our max number of fighting pets, and our dynamic array of fighting pets. I need a comma here, there. Okay, setting and getting our attributes. And we should say, maybe instead of a set for set and get name, max number of pets, number of fighting pets. So set and gets for those here, and then we'll have a method for add experience points. So we'll have a method for add experience points. And we'll say if your experience points goes greater than your level times 1,000, increase the level and reset the points to 0. Probably just the easiest way of going about it here. I'm sorry? The trainer is leveling up here. So you have a trainer level as well. So every time, as you add experience points, right, if it's greater than your level times 1,000, we'll increase your level and put your points back to 0. So every time to get the next level, you need whatever that current level is times 1,000 worth of experience points to level up. I don't know what the levels actually do for you, other than bragging rights, I guess. So I don't know. All right, so we can add experience points. So we're never going to set level directly. Like the way we interact with level, we can get it here. Let's set and get methods for level. Yeah, and experience points. And then we want to add a method for set. We don't really want to set the pet. We want to be able to like add a pet. So we'll have a method for add fighting pet. Adds it to the fighting pet array in the next open slot, or raises an exception if you have no more slots. So you get so many spots here, your max number of fighting pets at a time. So we'll also have a way to increase that amount. So we'll add a method for add more fighting pet storage or something. Remember, we can't really increase the size of our array. Right? Once you have the array, it's fixed in size, but you can make a new array and you can go through the old array, copy them into the new array, right? Looping through. Does that ring any bells?
Yeah.
Okay. We can look more at that next week when we talk about arrays and things. Or fighting pet storage, so makes a new array with a larger size and copies the fighting pets over. That's into the new array, right? Also, when you're dealing with dynamic memory, right? If you allocate new memory, you need to make sure we clear up the old memory, right? So make sure you delete that old array before it's gone forever, right? So sure you delete the previous array. All right, and then for fighting pets, sorry, we're just out of time here. We just need their attributes here. Fighting pet has attributes for name, number, and combat power. That's okay. Like your Pokemon number 7 or something. I don't know. Which one's Pikachu? I forget Pikachu. It was 21 or something? I forget. It's okay. All right, so yeah, for name, number, combat power, add that and gets, constructors, yada, yada, yada. Right. Nothing, they're not going to have any dynamic memory we need to worry about here. So we'll be okay. Just dealing with the dynamic memory with trainer here. Okay. I'll work on a rubric here in a little bit for you. You don't have to hang around for that. And then a link to get your repository out of the GitHub Classrooms as well. So I'll add that for you. All right, sorry, I don't mean to keep you late. I know you folks have other things going on. We can chat more about it next week.
Yeah, like 15 minutes away. Now you have an excuse to go home.
You can use anything you want. Okay. Yeah. It's fine. I think we can get away with using the trademarked term because we're not selling it, just for academic use. But it's also entertaining to come up with other things.
I did my final project a semester on Pokemon game.
Oh, did you? Okay.
Yeah, so
Nice.
We didn't have graphics or anything.
Yeah.
Like you enter which Pokemon you want to see. So
Nice.
you can choose your Pokemon. Except I have to change the names. I made it Pokemon. Yeah. So like Pikachu, it's what is it, Pichaku or something?
Okay.
Yeah.
Yeah.
It was fun.
Nice. Yeah.
So I recently just sent this last month one day.
Okay.
So I was just wondering, are you're doing the recording and stuff?
Yeah, I should actually hit stop, shouldn't I?